Hi students, so let's start our lesson today. It's paper 2014, it's variant 2, paper 1, um, physics, and the topic is electricity. This was your homework, so there are students who are finding some issues. So I'll explain each and every question so that it's like easy for you to revise for finals. Okay. So two positive charges and one negative charge, all of equal magnitude, are set at a corners of an equilateral triangle. Alright. Which diagram best represents the electric field surrounding the charges? Okay, so let's start from A. It's positive. It's going out and out, out and out, out. Okay, this is negative, coming inside, inside. So, okay, this seems correct. This is correct, and this is negative. So we know it more lines. It can't be like this. So this is not correct, and this is completely. So A is the correct answer for this. Okay. Now let's do the next question. Okay, the next part says that two oppositely charged horizontal metal plates are placed in vacuum. A positively charged particle starts from rest and moves from one plate to another plate as shown. Okay, it's going like this. So which graph shows how the kinetic energy of the particle varies with the distance x moved from the positive plate? Okay, this is an easy one. Since when our charge is moving from positive to negative plate, so actually its potential energy is getting decreased. So when the potential energy is going to get decreased linearly, the kinetic energy is going to increase linearly. So only this relation is the correct relation, and else this all are wrong. Since now my kinetic energy will keep on increasing until it reaches over here and it reaches the maximum distance. Okay, now let's start the third question. All right. Okay, now the third question, it says that a battery of electromotive force V, a negligible internal resistance, is connected to a 1 ohms resistance, 1 kilo ohms, okay, which is this one. Okay. A student attempted to measure the potential difference between point P and Q over here using 2 voltmeters, one at a time. Okay. The first voltmeter has a resistance of 1 kilo ohms. Okay, and the second voltmeter has a resistance of 1 mega ohms. What are the readings of the voltmeter? Okay, let's solve. Then we'll know. I'm solving it over here. Okay. Okay. So the voltmeter is actually connected here. Okay, between these two terminals, and the first one is actually 1 kilo ohms. So the voltmeter is connected in series with the resistor. Okay, so the potential difference across the component R1 is given by, so we can say that your V1 is actually equals to your R1 over R1 plus R2. This is the potential dividers formula. So right now, if you will see that your R1, which is the voltmeter's resistance, and the resistance over here, both are equal, right? So can you write it as, let's say that it is all equals to, R2 is also equals to R1, or R1 is equals to R2, okay? So in this case, R1 is actually equals to R2. So you can replace it with any number, like let's say R1 over R1 plus R1 into V, which is actually equals to V R1 over 2 R1. V R1 and R1 will get cancelled. So V is equals to actually V over 2. V1, sorry. Okay. So let's check the answers that for 1 kilo ohms. Okay, there are two answers which are, so you need to solve it further for 1 mega ohms also, because we'll consider these two answers now only, because this and this is wrong. Now let's solve for 1 mega ohms. Okay, so for 1 mega ohms, as you know that 1 mega is very much greater than 1 kilo. Okay, so we'll just take the condition over here as, like, again, it's V1 is actually equals to your R1 over R1 plus R2 into V. Yeah, but as R1 is too much greater than R2, so we can say that R1 plus R2 will actually lead to R1. Yeah, because the value of R2 is very small to affect R1. So can I write as V1 is actually equals to R1 over R1 into V. and this is going to get cancelled. So V1 is actually equals to V. Why I did R1 plus R2 as R1 only? Because the value of R2 is very small as compared to R1. So it is not actually affecting the whole ratio. So we can write it as R1. So the second answer for 1 mega ohms is V1 is equals to V, which is this. Option B is correct. Okay. Let's move to another question. Okay. Which is this one. Okay. Now let's see. All right. Now the question says, okay. Now the question says the diagram shows an electric pump for a garden fountain connected by an 18 meters cable to a 230 volts main electricity. Okay, so this is 230, this wire is 18 meters and this wire is also 18 meters. All right. The performance of the pump is acceptable if the potential difference across it is at least 218. All right. The current through it is 0.83. What is the maximum resistance per meter? Resistance per meter, not only resistance, of each of the two wires in the cable if the pump is to perform acceptably. First, let's see how much meter of cable actually we have. It is 18 plus 18, which is 36 meters in total we have the cable. So whatever resistance you are going to calculate, you just divide it by 36 and you will get the resistance per meter. All right, so let's do it by using Ohm's law. I will solve it here. Okay. So basically your Ohm's law says what? V is equals to I. Okay. So for the pump to perform acceptably, the potential difference across it should be at least 218, right? So the potential difference across the cables, it will be 230 minus 218. Yeah. So this minus this should be at least, this should be the difference, which is actually 12 volts. Okay. And the current through the electric pump, we know that it is 0.83, right? So the same current actually flows through the cable since it is in series with the pump. So the cable will have a total resistance of V over I, which is equals to 12 over 0.83, and it is equals to 14.5 ohms, right? And like if you see the diagram, yeah, if you see the diagram, you will see from the diagram that the cable is made up of two wires, right? Made up of this wire and this wire. Yeah, these two wires are there. So the total length of the wire in the cables is 2 multiplied by 18, not 18. This is a catch, okay? So you need to, the total length of the wire corresponds to the total resistance of 14.4. Right now, what the resistance you have calculated is for both wires. So you need to divide 14.5. This is 0.4 ohms per meter is the resistance per meter. Got the point? Okay.